Hey guys, welcome back. I know you were really hoping that we'd cancel the school year, but that didn't work out. So let's get to our last lesson. So the first thing you need to do is go on OSS Connect because I have a resource paper that's been posted. It includes some vocabulary, some pictures to describe that vocabulary, and the unit circle because you're still going to need it. So if you don't like my unit circle, find one on the internet. I don't care. All unit circles are the same by definition. So I am going to teach you today about how to graph the sine and cosine graphs. That's it. I was going to teach you tangent because I had time. No, I'm not going to do that anymore. So we're just going to do sine and cosine. Luckily, they look really similar. So you are definitely going to need your unit circle though. So if you don't have one open right now, get one. Okay, so I already pre-did my board just a little bit for the things that are really basic. So any graph that we ever do, you need a general function. So I've written the general function and I've prepared it. But I've only described the things that are on absolutely every single graph we've ever learned. And so we'll move on from there. So here is my wonderful, beautiful, what's the resource? Notepad that I've done. Okay. So I know that a lot of this will appear backwards to you because I don't really got much choice. There's only so much technology that I've got at this point. So the first thing that you need is that the sines function is y equals a times sine of b times x minus h plus k. Okay, and yes, there's a lot of parentheses, I get that, but we're still gonna have to do it. So I will flip the camera over at the very end so you can see all of these the right way. Actually, I can do that for just a moment so you can see what's going on. No, I can't, it won't let me change it. Oh well, you'll see it in a moment. I'll post up pictures. Okay, so the first thing that we needed to do was identify all the variables here. I have x and y are the same as x and y has always been. There's an x-axis and a y-axis. And then I have hk, which are still the same as ever. H is the horizontal shift and k is the vertical. So all I have left are that b and that a that I don't truly 100% understand. So I'm actually gonna come over to my graphs next. And it says y equals sine x is the first one I'm going to work with, and that's the one I'm going to work with first. So I have to first label the axes, because duh. So I have an x-axis and a y-axis. Okay. And I need to graph this. Now, here's where the unit circle comes into point. Okay, everything we're doing is going to be in radians. So ignore the degree measures. We're doing this in radians. So I know the sine measure at any of the radian measures circling that graph, correct? Well, you don't need to tell me correct because I know it. I can see the unit circle right now. So the first thing I'm going to do is label the axes accordingly. Now I know a unit circle goes from -1 to 1, and that's it. Okay, so that's all I'm going to go on the y-axis. I'm going to go from -1 to 1. Okay, that's all. All right, so next is I need to do the x-axis. Now, the x-axis is what I'm plugging into the sine function. So I want them to be radian measures themselves because then I can just plug them in and see what it says on the unit circle, and then I'm done with my life. So I know that my unit circle goes from 0 to 2 pi. So that's what I'm going to do. And I'm going to do this in a organized manner and hit all the axes. So I'm going to start at 0 because duh. So that's the corner right here. Remember the origin is 0, 0. And then I'm going to go pi over 2 to the right because that goes to the next axis on the unit circle. So that's what I'm going to do. So my next one is pi over 2. And then after that is another pi over 2. So now I'm at pi. Another pi over 2 gets me to 3 pi over 2. And then after that, I'm going to go another pi over 2, which gets me to 2 pi. Now you're going to want to do this on graph paper yourself because you got to see how this looks, otherwise you're not going to know what to do. So when I plug in pi over 2 to the sine function, what do you get? Now you should have all looked at your unit circle and looked at the y value because your y values are your sine values and your y value is at 1. So at pi over 2, I'm at 1. So I'm going to put a little point there. Okay, and I skipped the 0, which I shouldn't have. So if I plug 0 into the sine, check your unit circle and see what you get. What is the y value at 0? Okay, well, the y value at 0 radians is 0. So I'm going to put a point there too. Okay, and then we're going to go to pi. Okay, if you go around the unit circle to pi, check out the y value. What's your y value? Now, if you really actually look, you'll notice that your y value is 0. Okay, so at pi, I'm at 0. And then 3 pi over 2 is my next one. If I go to 3 pi over 2, which is downwards, I check my y value, and my y value says I'm at -1. So I'm going to plot this point at -1, which is in the middle of my number, but it's okay. And then at 2 pi, I go all the way back around, and I'm at 0 again and at 0 again. I check this, and it says that, oh, looky there, it's 0. So I just plot that too. Okay, now, this is a curvaceous kind of a graph. So when I draw the curves to indicate what's going on, this is what it's going to look like. Okay, so it'll look something like that. Let me get real close so you can see what I did. Okay, so it'll look something like this. Now, sine and cosine functions are never ending. It will be a curve that continues on forevermore, and you can continue if you really want to. I only require 1 period, and if you actually brought up the resource that I asked you to, it says a period is the horizontal distance required for the graph of a periodic function to complete 1 repetition. And this is 1 repetition. I have 1 upwards curve and then 1 downwards curve. That would be an entire repetition, because I can keep going, and if you want, I shall. And at the next one, I'll be at 1, 0, -1, 0. And this is what it would look like if I kept going, because it's going to be just a curve. Okay, now it's actually called a sine curve, and it is a definition that you can use. It's an English word you can also use to describe other things. So if you really want to look really, really cool and you see a curve that looks something like this, you could always call it a sine curve, and then everyone's going to be super impressed with your math knowledge and your English knowledge. It's going to be amazing. So if that's your choice, go for it. Okay, so here's the things that I didn't define about my general equations. Is I didn't define this A that's sitting right here. And I didn't define this B, which is way over here. Okay, so I didn't define either of those two things, which is kind of important. So if you look at your resource, there were 4 definitions I gave you. I gave you a periodic function, the period, midline, and amplitude. Now, the periodic function is just any function that repeats itself. So the sine and cosine are included, but there are other ones. I've shown you pictures. I put pictures up there, so woohoo. But that's not as important as the other 3. So a period, the midline, and the amplitude are most important, okay? So the midline is a horizontal axis that is used to reference the line about which the graph is periodic. So in the case of the sine x function, my midline is very easy to find because it's the x-axis. Obviously, because I go 1 up from this to get to the highest, and I go 1 down from it to get to the lowest, which means that it's in the middle. So for our midline, it's actually really easy to find. I'm gonna put this in a different color though, because we're gonna get crazy with these. Okay, we'll go in for green because I like green. Okay, so your midline is always going to be, when it is a horizontal sine function, it's always gonna be y equals k. Very simple. So your midline is y equals k. All right. So I have my midline, pretty simple, okay? It's gonna be extremely important to identify though, because if you can identify your midline and your amplitude, you can identify just about anything. So the amplitude of a function is half of the difference between the minimum and the maximum. So my maximum for my sine function is 1, and my minimum is -1. So 1 minus -1 is 2. Divide that by 2, my amplitude is 1. Okay, so there's the whole, let's plug this into a formula and figure this out nonsense. Another way to look at this is just look at the equation, okay? If I know what the amplitude is in the equation, then I don't have to do anything else, which is beautiful because we all are lazy. So according to the equation, that's where the A comes in. So the absolute value of A is the amplitude. Okay, the absolute value of A is the amplitude, which is extremely important. Okay, do not include the negatives. I don't want them. They don't mean anything when it comes to the amplitude. Now here's the part that includes a little bit of math, is to find the period of any function. Okay, I look at the original function, the parent function that I have right here, because this is the parent. And I know what its period was. Its period was from 0 to 2 pi, because that's exactly what its period was. So I need to know what the period of any sine function is, though. Okay, and that's where the b comes in. So the period of any sine function is going to be 2 pi divided by whatever your b is. Okay? Now, it can be literally anything. It can be a fraction, it can be a whole number, it can be anything. It could even be negative if it really wanted to be, but I will never give you one that's negative. It just can, okay? So from here, we need to keep going because I still have so much more to go over. So sine and cosine is what's next, or actually cosine is what's next because we just finished the first of the sine. So the parent function for the cosine is right here, and I know it appears backwards, and I'm not really sure what I can do to fix that, but I'll work on it for the next video. So y equals a times the cosine of b times x minus h, all plus k. Okay, now this is the cosine, which is great, but I want you to notice that it looks exactly like the sine. Okay, now it looks exactly like the sine for a reason. Okay. The only difference, okay, is that instead of, when you go on the unit circle, instead of finding y values, you're going to find x. Okay, that's the only difference. All right, so for this one, you're going to plug in radians. Okay, and it will spit out the x coordinate of the unit circle. And the sine will spit out the y. Okay, it's very simple. We've actually technically already done one of these, so that makes life a little bit easier. For everyone who feels that this is not super useful, I will post up more videos. So not all of them done by me, just in case you don't like me that much. No offense taken. So we'll go back over to my graph portion and try and graph the cosine. And then once we've graphed the cosine, we'll graph a couple of weirder ones, which I'll actually write down for the people who think that this is really boring. Okay, so we'll go to this one. I'll write it down. I want 4 sine of 2x. Okay, and I put it in parentheses to tell you that it's 2 times x. And then this one I'm going to do 5 cosine x. Okay. Okay, so there are the two I'm going to do. Oh, these are both equal y. My bad. Oops. Okay, so the cosine graph, okay, I'm going to use the same axes because I chose these axes based off of how we made the unit circle, and the x values are going to go the same way as the y. So I'm going to go up 1, down 1, or up 1, down -1, and then I'm going to do pi over 2 as the distance between every single of the tick marks from left and right. So this one will be pi over 2, and then pi, 3 pi over 2, 2 pi. I could keep going, but I'll just keep going with the number values because I know this will repeat. Okay, so if you pull out your unit circle again and you check what the x value is when I plug in 0 for the cosine, so what is the x value at 0 radians? The x value at 0 radians is 1, so that's what I'm going to plot. Okay, and then if I check the x value at pi over 2 radians, you're going to get that the x value is 0. Okay, and then continuing on the x value at pi radians, if I check the x value at pi radians, you're going to notice it's -1, so -1. And then at 3 pi over 2, you're going to get 0, and at 2 pi, you're back to 1. Okay, this one looks a little weird with how it stands, so I'm also going to go left and right. Okay, so if I go left on the unit circle, pi over 2, which means I go down to negative pi over 2, which is actually going to be the same thing as 3 pi over 2, you'll notice you're going to get 0. And then I'm going to keep going just to get a couple more points going in the negative direction. Okay, in the positive direction, I'm going to keep going also. So if I go another quarter of the circle around in the positive direction from 2 pi, I'm going to see that it's 0. And then another one, I'm going to see it's -1. And then I'm going to get 0 and then 1 again. So I'm going to give this its curve so you can see what it looks like. Please hold off on drawing your curve until you see mine, because you guys tend to not really understand what a curve is. You like to give me straight lines. That just is wrong. So this is what your curve will look like. And this is what the cosine graph looks like. Okay, not really all that different from the sine. Okay, it's an important difference that on the y-axis, okay, your y-intercept for the cosine is traditionally 1, and the y-intercept for your sine is traditionally 0. That's the extremely important part, okay? So you can still move these around. Now, traditionally, okay, well, non-traditionally, I guess I should say, non-traditionally, you can actually transform the cosine into sine. It's very simple to do, because the difference is I can see that the first value of 1 on the sine is at pi/2, and the first value of 1 on the cosine is at 0. So all I have to do is shift my sine left pi/2 or my cosine right pi/2, and I have the other one. So I'm going to write that down, but I'm probably not going to test you on that. So it's just something useful to know. If you don't like sine or if you don't like cosine, you can just use the other one by shifting it. So cosine x is going to be equal to sine. Okay, so if I'm turning cosine into sine, here's my cosine, which means I have to move it right pi/2. So this one is going to be x minus pi/2. Because remember, when it's inside with the x, you need to use minus, okay? And then if I'm going to go the other way, so sine into cosine, okay, I'm going to take my x value. Now sine needs to be moved to the left, so I'm going to add. So this one will be plus pi/2. Okay, very simple, not at all complicated. Once you've seen the graphs, it's much more obvious how this is going to go. Okay. So, next. All right, so I'm actually going to skip the sine and go to the cosine because I don't actually like sine, I like cosine. So I'm going to skip to that one just because I can, and then I'll go back to the sine. So my cosine says 5 times cosine of x. Okay, well, if I look at whatever I was doing at any given time, and in this case, my amplitude from my originals, okay, they both have the same amplitude, and you can actually see it because it's the distance from the x-axis to one of the maximums or minimums. So I've drawn it right here in this red. You can see it right there. Okay, so that's its amplitude. It tells me how far away from my horizontal midline am I gonna go, which is extremely important, because if you know that, then you can kind of just use the parent function and then just go from there. So I need to know important facts about this. So I need to know the period, I need to know what its amplitude is, and because if you don't know its period or its amplitude, you don't know how to label the axes. So in my case, I'm going to check both. Now I know the period is 2 pi over b. So if I look at my equation and I wonder what the b is, because I don't see a number listed, I have to assume it's 1. Okay, so b is 1. I'm going to use a different color. I have a few. Okay. So b is 1. So my period for this one is going to be 2 pi over 1, which is just 2 pi. Which means I should complete the entire period, which is one curve upwards and one curve downwards, with between 0 and 2 pi. So I'm actually going to label that. Okay, now I want this to fit within about 4 different sections. So I'm going to keep the same scale basically as I did for the x-axis of the originally, because I haven't changed anything. So it's going to be pi over 2, or 0 pi over 2, pi, 3 pi over 2, and 2 pi. Okay, that should be enough for my whole amplitude. I know I keep going, but it's not required. I want to see one full period, and you don't need to show me more. Now, if you want to show me more, there's nothing wrong with but you're gonna get a worksheet for this later, and it doesn't really have a lot of room for extra periods. Okay, so now I need my y-axis. Now my y-axis comes from my amplitude, okay? I need to know what my amplitude is so I can decide how high I have to go, because it tells me how high the graph is. So if I look at this, it said that the amplitude is the absolute value of A. I say it as in my paper. My paper says absolute value of A is the amplitude. So the absolute value of 5 is the amplitude. Now the absolute value is the distance from 0. 5's distance from 0 is still 5. So this is still 5. Which means that I'm going to actually scale my y-axis in some way to represent this 5. Now I didn't make it very tall, I only went 4 tick marks, so I'm actually going to label these as 5s. So I'll say 5, 10, 15. It won't show you how much taller this is, so you know what? I can extend my drawing. So I'm going to extend it in both directions to get the 5th. Okay, so I'll actually go by ones, which is important because I want you to see how it's stretched. Okay, you don't have to label all the way up. I just need to see the scale. So from here, I'm going to pick the values and plug them in. So cosine of 0, if you check your handy dandy unit circle, cosine of 0 is 1. But I have this 5 out here. So 1 times 5 is 5. So at the y-axis, I'm going to be all the way up at 5. Okay, and pi over 2, I need to know what the cosine is. Pi over 2, the cosine is 0. The x value is 0 on your unit circle, so the cosine is 0. So I plug it in, and 0 times 5 is still 0. So I don't really need to change anything. At pi, I need to check my cosine. My cosine is going to be -1. Okay, so -1 times 5 is still -5. Okay, so -5 is way down here. 3 pi over 2. Okay, if I check the cosine of 3 pi over 2, you're going to see it's 0. Okay, so 0 times 5 is still 0. And then the cosine of 2 pi. Cosine of 2 pi is 1, and 1 times 5 is 5. Okay, I'm not going to keep going like I did in the cosine at the top because I just want one period listed because I got to keep going, and this video is already getting long. So continuing, if I draw my curve, that's a much longer curve. So you can see the parent here, and you can see my new one. It's kind of stretched it quite a lot. So that's what happens when the amplitude gets bigger. Not a massive deal in reality, because you know what sine and cosine graphs are used for? Oh yeah, that's music. Okay, sine and cosines are used for computers to interpret music, and so it can spit it back out at you, and you can listen to your music whenever you want, wherever you want, with the use of an electronic device. So moving on to the sine that I have listed here, and then I'll post up more videos, we'll do more examples. For now, I just need you to understand how to draw any of these, and then we'll practice so you can get good at it, because this is what I'm testing you on, just so you know. Okay, so for this one, I still need its period and its amplitude. Well, the amplitude is really easy to do, so I'm actually going to do that one too first. So I'm going to put it right here as A and P. So the amplitude is absolute value of 4, right? And the absolute value of 4 is 4. So my amplitude is 4, and my period is 2 pi over b. Okay, well the 2 pi is generic, so I write that. And then the b is the number right here. Okay, it's the 2. So you have to be extra special careful, because sometimes they'll distribute that b. And if they distribute the b, it won't match with the parent functions. And if it doesn't match with the parent functions, it won't follow all of its properties. So you'll have to factor it back out if that's true. Will make another video for the worksheet I give you that'll show you how to do that. So don't worry about that for right now, just focus on this. Okay, so my b is 2. So when I take my 2 pi and I divide it by my b, which is 2, okay, I'm actually going to get that my period for this one is pi. So I only need to go to pi to know what any of these values are. Okay, so again, I'm going to split this up into 4 because that's how the unit circle is split up. There's 4 quadrants. I want 4 values. So I'm only going to go to pi though. So I'm going to take pi and I'm going to divide it by 4 to find my scale. So pi divided by 4 is obviously just pi over 4. Don't plug that into a calculator. There's no point. Okay, so I'm going to start at 0, and then I'll have pi over 4. And then pi over 4 plus pi over 4 is 2 pi over 4, which is pi over 2. So I'm going to put that one. And then pi over 2 plus pi over 4, which is 2 pi over 4 plus pi over 4 is 3 pi over 4. So that's what's next. 3 pi over 4. Okay, and then another pi over 4. If I add one more pi over 4, I'm actually going to get pi. So, woohoo. I have 4 points, and now I need to check them using some math. This one I'll use a little bit more math because my period is different. So in this case, if I take pi over 4, I'm sorry, which is my, well, 0. Well, let's start with 0. So 0 times 2 is 0. So I need the sign now of 0. Well, the sign of 0 is 0. Okay, so I'll put a point at the origin. Now, if I take pi over 4 and I multiply it by 2, because it's got 2 multiple right here, I have to do that first. So pi over 4 times 2 is pi over 2, I believe. So somebody can disagree with me later if you disagree with me. So I need to know what the sign of the pi over 2 is. Okay, well, sign of pi over 2 is 1. And then I have this handy dandy 4 out here. So 1 times 4 is 4. So at pi over 4, I'm at 4. So 1, 2, 3, 4 right here. Okay, so next is pi over 2. Pi over 2 times 2 is pi, right? Because the 2's cancel and it leaves you with pi. So pi, if I plug that into sine of pi is 0 if my unit circle is correct. So 0 times 4 is still 0. Okay, so the next one is 3 pi over 4. So 3 pi over 4 times 2 is 3 pi over 2. And then sine of 3 pi over 2 is -1. And then if I take -1, I have to multiply it by 4 because that's my amplitude. So times 4, and I go way down here, and I've got a point. Okay, and then last but not least is pi, because that's my full period. So if I take pi and I multiply it by 2, I get 2 pi. And then I just plug that into sine. So sine of 2 pi is 0. So 0 times 4 is still 0. Okay, so if I draw my curve, because I know what the sine sort of looks like, I will get that. And there's your weird sign for your new one. Okay, so your period did change, which isn't great, but it happens. So remember, this is so you can continue to enjoy your music. So here's the lesson so far. I want you to make sure that you go over it. You can go over it as many times as you want. I'll put up a picture of this at the end. So if something was weird because it was backwards, you can check it and you can rewrite it. But I want you to make sure to review this because you're coming with me tomorrow between 9 and 10 a.m. So you have to be awake. You're going to come to me and you're going to ask me any questions. If you have no questions, you still need to check in with me for attendance purposes. Okay, if you get marked wrong, if you get marked unattended so many times, they can hold you back a grade. So make sure to check in with me. Once you check in with me, if you still have no questions, you can sign back out. That's fine. Okay, so I will talk to you guys later.